Here we have the subroutine for reading a matrix. So the subroutine arguments are A, the matrix, and its size. I assumed here n by n. So this subroutine is limited to read the square matrices, and IU is the unit number, which is the ID for the file, which is to be specified in the main program. Then the integer definition real matrix, integers ij. Well, this is the style to declare separately the arguments and then the variables which are occasionally required. And yes, this is reading with the one outer loop and one implied do loop. Return and subroutine is there. Now, let's assume that we would like to read this data matrix to the .inp file contains a 5 elements in one row, and there are four rows, right? So now let's write a main program, read matrices from this file. These files are stored in our bin directory, in which our compiler G77 is there. And our library file CF library, we can see its address G70 D directory G77, subdirectory G77, subdirectory bin, and here is the file. So I write the name program matrix example 1 and end program matrix example 1. Implicit none, so that we have information about all of our variables and there is no doubt about our variables. So I define the fixed arrays real trace 5 by 5. I define real bulk modulus say 3 by 3. I define integers I, j, k, and integers say the unit number for input file, let's say ID of file. It is good to have the definition ID for file, for input, ID for input file. Now let's go for initializations. So I write IDF equals and okay, can directly give the name of the file, but it is good to declare a character variable that can store 20 characters. I say in file, input file, I use in file. So let's initialization and I file, the name of the file I would like to read 2D where the matrix data is present. So it is defined. Now we have to have an open statement. Open the keyword unit IDF. Then the other is the file specification. So I say ifile, it's a character variable, and the third character is the status. Status should be old because we are going to read the data from it. So later on, you will see that in the open statements, there are some other attributes as well. So the minimum number of attributes are these. Now we have the file name and the ID of the file. So I can read. So I call reading function, reading routine from from CF library dot for. Of course, we don't have to specify anything in the main program. We have to do this step during the compilation. We have to compile this program that contains the dependable functions in the CF library. Okay, let's first save it. So in the bin directory, the main program should be saved as Fortran source file, matrix example1.for. So as I write this line, so people generally define the programs. So mat x1.for is matrix example1. So I call the library all for read matrix stress 5 by 5, and from unit I stress matrix size 5 by 5, and from unit ID, and call the writing routine write matrix stress 5 by 5 and unit 6, which means the default printing on command window. So a reference has been made for the input file, and reading will be performed in writing. Stress. Okay. So program has been saved. Let's run it. So I write B77 matrix example1.for cf library.for -o matrix example1.exe. So stress. The first is stress. Invalid declaration. So it rightfully points out where the error is. Again compile. Second attempt. Compilation is successful, and let's run it. Matrix example1.exe. Okay. So reading started. It get to the end of the file during the reading process, right? So unit 10 as IDF, the ID for the input file was set equal to 10. So if I see the input file, so my attempt was to read a 5 by 5 matrix. So, but right now it is a 4 cross 5 matrix, right? So the program attempted to read the 5th line and there was nothing, right? So that's the error message. So let's provide 1 0 0 3.2 4.5 5 values. Fran will keep looking for the values, right? I can write these values in this line, and these can also be written over here. Now let's compile the program once again. It is successful. And then, so now you can see a 5 by 5 matrix has been printed. In order to remain aware with what is going on with the program, since it compiles and then during the execution, it encounters the error. So to check that, generally we use print statements so that we have a confidence that up to this point, the program has successfully executed. So I write here print successful variable definitions, and then I write start computations, and then blank lines improves the readability of your code. I write reading of metrics successful. Okay. Then the writing step. So with this one, let's see how it facilitates compile and run. So successful variable definitions, start computation, reading of metrics successful, and then writing successful. So it is very important, since computer is going to provide you a facility to speedily do the computations. However, you have to provide the data. And with computers, it is true, garbage in, garbage out. If your data is corrupted, no matter how nice is your algorithm, you will get meaningless results. Now I do another thing with the file. So this is, this point it is completed. And I have defined another vector, another matrix, which is 3 by 3. So with the reading statements, so far it has gone to this point, right? If there is further data, we can read on. But for example, if I assume that the part of this matrix, for example, the 3 by 3 part, this matrix contains the bulk modulus, the other vector. How I can read that from the beginning of the file, right? So there is an option in the file reading, read some more data. So I write a word rewind IDF. It will get back to the first point again, rewind. So now I read the other matrix, call no yes, reading all read matrix. That's the facility provided by the Notepad++. So it helps you that these are the things related to your program. Are you interested in writing read M, something else? So I say read M, bulk modulus, which is 3 by 3, and the unit IDF. And then we can call it, we can call the write M. Of course, one line should uh, be left blank to improve the readability. Bulk M, it's a 3 by 3 IDF. So file operations. In the other programming languages, once you have completed reading and writing, so you should write close the appropriate unit. In Fortran, after the reading is completed, the files are automatically closed. So let's compile. So the part of output, part of matrix represent our other matrix. So compile with the library. and then see the results. Okay. Did I use correctly the right M bulk modulus P by 3? Oh, not IDF. Oh, that's very interesting. I printed with the right M statement and I printed on the IDF. So let's see what happened to IDF. Nothing has happened. So it means it has ignored that one. I should write here 6. 6 to print on the console. CLS, compile again, and embed. So file was reminded, and then the data was taken. So you can also read some other variables, A, B, C, and whatever you like.